Hi, this is part 2 of lesson 6.5, solving equations by factoring and completing the square. And as promised, we're on the second 3 questions under this special factoring cases because we don't really have to factor at all. So let's take a look at D here. We have x minus 3 squared plus 49. Well, if this said a squared equals 49, from the last lesson from the last video, we should know that that answer would be a equals plus or minus the square root of 49, which is equal to 7. Well, it doesn't say a squared equals 49. It says that x minus 3 squared equals 49. So then that means, I'm just going to cross that off, but I'm going to leave it there. It means then that x minus 3 equals plus or minus 7. So that means that x would have to equal plus or minus 7 plus 3, which gives us 2 separate answers where x equals 7 plus 3, which is 10, or x equals negative 7 plus 3, which equals negative 4. All right, so this is not by factoring, and this is kind of by completing the square, but it's not fully completing the square. You'll see what I mean in a second. So instead of expanding, again, this only works. These two methods only work when you have your x is being squared and you don't have a single linear term in your question. As soon as you throw a linear term in there, then it's not going to work. Now you can see that these are almost in vertex form. If I was to bring this minus 5 over to this side, minus 2 times x plus 1 squared plus 5 equals 0, that's vertex form right there. This is talking about a parabola where the vertex is at negative 1, 5. But knowing where our vertex is doesn't help us at all on trying to find out where the x-intercepts are, which means that knowing that this is in vertex form is in no way helping us at all to state what the roots are. So when you have just a bracket being squared and no other x, so I'm going to erase this. That doesn't matter anymore. You've got a bracket being squared and there's no other x in the equation. A bracket being squared and there's no other x in the equation. This is an option for how you can solve it instead of factoring it, instead of expanding and factoring, because maybe it's not even factorable. So now what we want to do is first we want to isolate that bracket. I'm going to erase that. Okay, first we want to isolate that bracket, and so to isolate it, we're going to divide both sides by negative 2. So that's going to get rid of that negative 2. That gives us x plus 1 squared, and then on the right-hand side, we're going to have positive 5 halves, or positive 2.5, and I'll let you do decimals for this. So that equals positive 2.5. Which means then that x plus 1 would equal plus or minus the square root of positive 2.5. Okay, just like we did back here. If this said a equals 2.5, if it said a squared equals 2.5, then that would mean a equals plus or minus the square root of 2.5. Just like here, if a squared was 49, then a would equal here plus or minus the square root of 49. You have to take the square root of both sides. Then you have the two scenarios. Bring the 1 over to that side. You got x equals minus 1 plus or minus the square root of 2.5. So you've got two answers where x equals negative 1 plus root 2.5 and x equals negative 1 minus root 2.5. Then you get your calculator out and you say, all right, negative 1 plus the square root of 2.5 I get an answer of about 0.58. And negative 1 minus root 2.5, I get an answer of negative 2.58. All right, and for f, we need to get rid of this negative 1/3 first, and an easy way to get rid of a fraction is to multiply by the denominator. So I'm actually going to multiply by both sides by -3. That'll get rid of the negative sign. It will also get rid of the 3. So I'm left with, on this side, x minus 2 squared equals -24. Now, let me just take a look at this. If this said a squared equals -24, that's saying, what can I multiply by itself to get a -24? And I hope all of you are saying, hey, Miss Meisner, that's not possible. Because if a is, say, a negative number, when you square that negative, you're going to get a positive. And if a is a positive number, when you square that positive number, you're still going to get a positive. So this is actually not possible. You can't say, and again, really what we're doing here, a would have to equal plus or minus the square root of -24. Not possible. And that means there is no solution. Now let's just take a look at Desmos and see what's happening here graphically. Why is there no solution? So let's go back here. I'm going to delete these 3. So basically what we're doing is we are trying to solve the equation where one side equals y equals -1/3 x minus 2 squared. That should be equals there. Let me back that up, put an equal sign. And a negative, there we go. Y equals -1/3 x minus 2 squared. And the right hand side is y equals 8. Y equals 8. And remember, the solution to this is where these two relations intersect. We'll take a look. The purple graph is y equals 8. The green graph is the parabola. They are not intersecting at all. So there is no solution to this. And if we take, let me just go back here. If we take this problem and I bring everything over to one side, we get -1/3. I don't know where that came from. -1/3 x minus 2 squared, bring the 8 over to the other side, that's -8 equals 0. There's a parabola, it opens down, and it's the y coordinate of its vertex is at -8. Well, what does that look like? Let me just graph that one. I'm going to hide those two. Hide. Y equals -1/3 bracket x minus 2 squared minus 8. Here's that parabola. It's opening down and its vertex is below the x-axis. The y-coordinate of the vertex is a negative value. It's opening down. This parabola is not crossing the x-axis. It has no x-intercepts. So if that parabola has no x-intercepts, when you make the equation equals 0, the resulting parabola or the related parabola, if it's not going to cross the x-axis, then there are no solutions to it. So here's a situation where, you know, sometimes this happens, where there is no solution to an equation. It happens sometimes. And if you're doing one that like this, where you just have that x squared term, then if the right-hand side is negative and the left-hand side is positive, so the squared side is positive and the other side's negative, there is no solution. All right? Okay, so that leads us to solving by completing the square. So what this is saying is, okay, complete the square and then solve that equation, because I don't know if this is factorable. This says two numbers that multiply to give you negative 14. So you're looking for two numbers that multiply to give you negative 14 and they add to give you negative 4. I don't know of two numbers that do that. So we can't do this by factoring. Certainly we could do it by just graphing it in Desmos, but that's not the point of this. This is really about how to do these things algebraically. And so what we are going to do is we're going to complete the square. Now, I'm going to tell you something right now, that we would probably not do this very often, because the method that I'm going to show you in the next lesson is going to do this for us. But I just want you to kind of go through the process. So this is kind of like the pain, and tomorrow I'm going to give you some aspirin. Okay? So this completing the square stuff right now to solve an equation is it's a bit painful. And tomorrow I'm going to give you some aspirin to get rid of that pain and make it so much easier. But for now we're going to do it. Okay, completing the square. Step 1 to completing the square, you take the first two terms and you factor out the a value. So you get x squared minus 2x minus 7 equals 0. Then you complete that square. So that's 2x squared minus 2x. Now remember, we're taking the negative 2, divide it by 2, and square that. So that's negative 1 squared, which is equal to 1. So minus 2x plus 1 minus 7 equals 0. Then you keep these three together. They are going to be x minus 1 squared. And then you multiply the 2 times the negative 1. So that's minus 2 minus 7 equals 0. Now I have a situation where all there is this. The only x I see is this x here, and it's inside a squaring. So we can do it the same way we just did the last three questions. So bring this over to the other side. So 2x minus 1 squared equals 9. The minus 2 and the minus 7 come over to the other side, which is 9. And then divide everything by 2. So x minus 1 squared equals 9 halves. You can leave it as 9 halves, or in this case, you can make it 4.5, but you know me, if that was like 9/7, you'd have to leave it as 9/7 because I want your answers to end up being as exact as they can. Don't round your answers yet. So then x minus 1 squared would equal plus or minus the square root of 45. Whoops, get rid of that squaring there. So x would equal 1 plus or minus the square root of 4.5. So we've got two answers where x equals 1 plus root 4.5, and the other answer where x equals 1 minus root 4.5. And according to my calculator, 1 plus root 4.5 is equal to about 3.12. And on the other side, 1 minus root 4.5 equals about negative 1.12. Okay, let's do another one. This needs to be simplified first and everything brought over to one side. So we've got 2x squared minus 5 equals, that needs to be expanded and that needs to be expanded. So this is going to be a minus 2x squared minus 6x plus 2 times 20 is 40, and then minus 2x. Bringing everything over to one side, we've got a 2x squared. This 2x squared is going to go over. It's going to become a positive 2x squared. The minus 6 and the minus 2x are going to come over. They're going to be a plus 6 and a plus 2x. And then the minus 5 is still there, and the plus 40 is going to become a minus 40. So this is 4x squared plus 8x minus 45 equals 0. This might be factorable, I don't know, but we're not doing it that way. We're doing it by completing the square. So we're going to take these first two. That gives us a 4. Remember, with completing the square, this isn't partial factoring. Partial factoring, you would take the x out as well, but we don't use partial factoring to solve an equation. We use partial factoring to find the vertex. All right, so I know there's a lot of different things that we're doing here with all this quadratic stuff, and we'll do a summary at the end of when you use what. Completing the square can be used to find the vertex. It can also be used to solve an equation. Factoring can be used to find the x-intercepts. It's also used to find the solution to an equation. But that whole partial factoring thing that we did, it is only going to be used to find the vertex. So taking the 4 out of these, we've got x squared plus 2x minus 45. You want to do 2 over 2 squared, which is 1 squared. That's x squared plus 2x plus 1 minus 1 minus 45. Remember, whatever you add, you have to also subtract. These 3 here will be x plus 1 squared, and then the 4 also needs to be multiplied by the minus 1, so that's a minus 4 minus 45. Bring the 4 and the 45 over to one side. That's going to give you positive 49. Divide both sides by 4. 49 is a perfect square, and so is 4. So this is going to be x plus 1 squared equals 49 over 4. And then square rooting both sides. That's square root of 49 over 4, which is actually 7 over 2. Because the square root of 49 is 7, and the square root of 4 is 2. And then that's plus or minus. So x equals negative 1 plus 7 halves, or x equals negative 1 minus 7 halves. When you put that negative 1, that 1 goes over to the other side, it becomes minus. So negative 1 plus 7 halves is 5 halves, and negative 1 minus 7 halves is negative 9 halves. Okay, I think that's it. Here's your homework. Page 320, 6AF, 7AD, you can read. For these 3, you're going to use factoring. For this one, you're going to use technology. And you can use technology all the time to check your answers. These 3, I would like you to do by completing the square. Or sorry, 4. There's 4 of them there. I can't count. Okay, I will see you in the next lesson. And always, 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 if you have any questions, please feel free to ask.